Okay. So the last class we have discussed what is deterministic finite automata and what is non-deterministic finite automata, right? So in the case of deterministic finite automata, from each state, for each and every input symbol, there will be a transition, and that transition will be for only one state, right? That the transition will be for only one state. That is Q cross sigma will have a transition to Q. So this is with respect to uh, deterministic finite automata. When we talk of a non-deterministic finite automata, from each state, uh, it is not mandatory to have a transition at all for each and every input symbol. So here you can see, right, from Q1, for input symbol B, I'm having a transition. I'm not having any transition for input symbol B, right? Similarly, like this, it goes on. When we talk of this state Q0, for input symbol B, I am having transition to Q0 and I am having transition to Q1, right? So here that's it. That is Q cross sigma will have a transition to 2 per Q states. So here please make a note, in the case of deterministic finite automata, we will have transition to only one state. Yes. So whereas in the case of non-deterministic finite automata, we will have transition to 2 power Q state. So the rest of the tuples, so with respect to tuples are all same, only with respect to transition function, we have to note this difference, right? So okay, so here in this case of non-deterministic finite automata, we are having here if we talk of non-deterministic finite automata, there are two types. One is going to be NFA with epsilon transition and NFA without epsilon transition. Epsilon is nothing but empty transition. On empty transition, we can have a transition from one state to the other in the case of non-deterministic finite automata. What we have seen here is nothing but NFA without any epsilon transition. There are no empty transition. Empty in the sense without any input symbol, without with an empty string. With an empty string, I'll be having a transition from one state to another. How to construct this epsilon transition from a given regular expression, right? Okay, so here, yes, from a regular expression. So here you can see already we have, so what is a regular expression? This is going to be called as the regular expression, right? And so here if we talk of, okay, what is a regular expression? Already we have seen operations on languages, right? So what are the operations? Operators we have seen. Okay, here you can see what are the operators we have seen. Union operator. So union operator, so which can be represented by this bar symbol or union or this one. And next we have seen concatenation operator. That is A concatenated with B is represented by AB, right? And then clean closure and positive closure. These are the operators we have seen earlier, right? So using these operators, we can represent a language by means of regular expression. So here, what about the language? In NFA, accepting the language of strings ending with AA. So here, AA, it is going to be the last part. Whereas what about the front part? I can have any combination of these. I can have BAA, I can have BAA, I can have just BAA, I can have AA, BAA, like this it goes on, right? So how we can represent this part? So this part can be represented only by this one. What about this part? This is not a fixed one, right? I can have any combination of A's and B's, and then it can also be indeed even. How we can represent? It can be represented by A or B star, right? So this first part can be represented by A or B star, and the next part is represented by A. Now what we can do, I can proceed with the concatenation operation, right? A and B star concatenated with A concatenated with A. Right. Similarly, let us consider I want to represent a language of string starting with A and ending with B. How I can represent? So we are starting with A, ending with B. In between, I can have anything, right? In between, I can have anything. So how I can represent A or B star? A concatenated with A or B star concatenated with B. Okay, so this is going to be the regular expression. So here now what we are going to do is we are going to deal with an algorithm. So please make a note. Till this point we have designed the finite automata based upon logic, right? So based on logic we constructed the finite automata. Now what we are going to deal now is going to be based on the algorithm. Okay, so your algorithm is going to be a very straightforward method. At least in till this point even we have to think of to proceed with the constructing a finite automata, whereas from this point on we are going to use the fixed algorithm. From this fixed algorithm we are going to proceed with constructing the automata. Okay, so first what we are going to do is constructing an epsilon NFA. Constructing an epsilon NFA, that is epsilon NFA is nothing but NFA with epsilon transitions from a regular expression by means of Mcnaughton, yamda, thompson algorithm. So the algorithm what we are going to deal is called as Mcnaughton, yamda, thompson, which is named after their inventors, right? This algorithm is proposed by Mcnaughton, yamda, thompson. Right. So here, what about the algorithm? So here we have to make a note of all these rules. Okay. So using this rule only, we are going to proceed with designing the algorithm from the given regular expression. Okay. So in the case of first step of the algorithm, we have to first construct a parse tree. Okay. What is a parse tree? I think hope we can deal it after seeing the rule. Okay, first we have to construct the parse tree, and from the parse tree using this rule we can easily construct the non-deterministic finite epsilon NFA. Okay, so here what about the rule? So here if we talk of the rule, it is going to be divided into basic rule and that is basis rule and induction rule. So basis rule is nothing but the base level for input symbols, epsilon transitions. We will be dealing with this basis rule, and the induction rule is for dealing with the operator. So please make a note, if a regular expression is handled only input symbol, right? So only input symbol, then in that case I will be dealing with this basis rule. So if we come across the if you are having any operators involved in regular expression, then in that case we will be dealing with the induction rule. Okay, so we can proceed with this is going to be the base rule. So here for if a regular expression, right? So if a regular expression is having only epsilon, okay, please make a note. It will be clear for you when we see example. Just by seeing a rule, you will not have any clarity. But please make a note of what.
Hello, ma'am. Ma'am, your voice is not clear, ma'am. It's low, very low.
Actually, my network connection is also good. How about now? Is my voice clear now?
Ma'am, it's very low pitch.
Okay, how about my voice now? Again, not clear.
Ma'am, it's okay, ma'am.
Okay, fine.
Now it's fine.
Okay, so please make a note of these transition, sorry, this is these rules. Okay, so if my input symbol, so if I am coming across only if my regular expression is having only epsilon, okay, so my regular expression is having only epsilon, so in that case then I will be introducing two new states. One is going to be the initial state and the next is going to be the final state, and then in the label, the transition between the new start state to the final state will have the label as epsilon. Okay, so please make a note. Suppose I'm having a regular expression as epsilon. Epsilon is only my regular expression. Okay, so in that case I will be having a start state. Let me call the start state as 0 and then my final state as 1. Okay, so then this transition will have a label as epsilon. And this is a case when my regular expression is epsilon alone. If suppose my regular expression is b, if my regular expression is b, then in that case I will be introducing a start state. Let me call this start state as q0, and then there will be a final state. Let me call this as q1, and the label will be this one. Right, so this is the case if my regular expression is having the input symbol or epsilon alone, right? So what about the operators? Already we have discussed certain operators, right? That is union, concatenation, clean closure. If my regular expression, so as you all aware, the regular expression will be having all these operators involved, right? So in that case, what is the functionality? That's what we are going to deal now. Okay, so here this is going to be the that is from the lower level we are going to move on to the higher level. Okay, so here this is regular expression S and this is regular expression that is, this is one regular expression and this is another regular expression. Okay, this is one regular expression, this is another regular expression. For these two regular expressions I am going to perform the union operation. So for example, in my language, let us consider I can have either A or I can have either B. Okay, I can either have A or B, or let us consider in my language I can either have uh, um, 0 or I can have 1, right? So I can have 0 or 1. So rest of the things are not possible. Okay, so in that case what I will be having, so one of the regular expression will be 0 and the next regular expression will be 1, and the it is going to be the OR operator. Okay, in order to represent the language for generating 0 is going to be this regular expression. In order to generate the language that in order to represent the language that generates 1, I will be having this regular expression. And what is my final language? It is going to be 0 or 1. For that I will be using this OR operator. Okay, so similar to that, I am having one regular expression which is represented by S, and I am having another regular expression which is represented by T. For that I am going to take a union operation which is going to be called as R. Okay, which is going to be called as R. How to convert this regular expression to its equivalent epsilon NFA. So please make a note over here. So I am having two different regular expression. For that regular expression I am going to take union operation. Okay, so using the basis rules or using the previous rules, what we will do is we will be constructing, we will be already having an NFA for S and we will be having an NFA for T. Okay, so already we will be having NFA for S and NFA for T. So from this NFA I am going to construct the NFA for regular expression S or T. Okay, so how to convert it? I will be introducing two new states. One will act as the final start state and one will act as the final state. So from this final state I will be having from the start state, from this new start state I will be giving epsilon transition to the old start states. So this is the old start state, that is, this is the NFA state of S and this is the NFA state of T. And this NFA will be having a start state and final state, right? So here in that final start state I'll be giving this epsilon transition. So from this new state to the old NFA state, I'll be giving an epsilon transition, and from this state to this state, I'll be giving an epsilon transition. And again I'm having a one more new final state, right? I have to incorporate to this particular NFA. So how to incorporate from the old NFA to new NFA? I'll be having an epsilon transition, and from here to here I'll be having an epsilon transition. So let me repeat, it will not be clear for you at this point of time. Only if you see example you will get the clarity. Okay, so here this is how we are going to proceed with constructing the NFA when we come across a OR operator. So what about the concatenation operator? Next we are going to deal is the concatenation operator. So how we are going to proceed when dealing with the concatenation operator? So please make a note. Here again we are going to proceed with concatenation of two regular expressions. So already I will be having an NFA for S and I will be having an NFA for T. So how we are going to proceed with constructing the NFA for R? So what is NFA for R? R is nothing but S concatenated with the T is going to be represented by R. How to design the NFA? Here this is the NFA for S and this is NFA for T, right? What we are going to do is, in order to proceed with the concatenation, the final state of NFA of S and the start state of NFA of T are going to be merged. Okay, so instead of two different states, I am going to have a single state for both, and it will act as the intermediate state. Okay, final state of NFA of S and start state of NFA of T will be merged and become the intermediate state. So this is with respect to the concatenation. And next comes the clean closure. So here I am having the that is S, clean closure of S. S is a regular expression. For that S, I am going to give a clean closure. So how to give the clean closure? So here how to construct the NFA for that? So here please make a note. Here only we will be adding some additional transition. Okay, so here while giving the transition you should be careful with the direction of transition. So here you can see this is the NFA for S. So this is the NFA for S which is already existing. So what we have to do, we have to give the clean closure of S. So what I'm going to give, I'm going to introduce two new state. One is initial and one is final. From this new start state to the old start state, there will be an epsilon transition. And similarly, old final to new final, there will be an epsilon transition, and old final to old start, there is an epsilon transition, and new start to new final, there is an epsilon transition. These are the additional transitions and additional states you need to be incorporated for constructing the epsilon NFA for a clean closure. Okay, so this is with respect to the rule for clean closure. So next is going to be brackets. So one more operator what we used to see is the brackets, right? So yes, here you can see. So what is ARB star? So will it make any difference, right? So in order to give here please make a note, when we talk of the operator precedence, similar to the arithmetic operators, these operators will also have the operator precedence. Okay, so here brackets will have, as usual, have the highest priority. Next comes the clean closure, next comes the concatenation operator, concatenation, and finally the OR operator. Okay, finally the OR operator. So for example, if I am having, okay, AB star, AB star. So what is the meaning? So I have to first evaluate this regular expression, and then only it is going to be concatenated with A. So or else let us consider A or B star. Okay, so here within brackets I am having OR operator. Okay, so what I have to do, so brackets have the highest priority. So first this will be first evaluated, and then I will be proceeding with the concatenation operation, and then clean closure operation, and then we'll be proceeding with the concatenation. Okay, so precedence of operators will be first comes the brackets, next comes clean closure, next comes concatenation, and next comes the union operation. Okay, so here, as you all aware, A or B and A or within bracket is going to be the same. Okay, so that's what, so yes within bracket is equal to R. So here in this case NFA for R and NFA for S will be the same, right? So I hope you would have noted down all the rules of conversion from regular expression to NFA. Now what we are going to deal is going to start with an example. So here what you can infer from this particular language, from this particular regular expression, what you can infer from this particular regular expression. What type of language it is? What does it represent?
Ending with ABB.
Yes, good. Ending with ABB. In front I can have anything. Okay, so here we are not going to deal with any logic and all, just a straightforward mechanism by incorporating all these rules. The only thing is that you should be knowing these rules. Using these rules we can directly proceed with constructing the epsilon NFA. So first step is to construct the parse tree. So here comes the role of the precedence of operator. Okay, so first comes the construction of parse tree. So here what is the thing? I have to proceed with constructing the parse tree, right? So here already we have discussed brackets. Brackets have the highest priority, so this needs to be first evaluated. Okay, this needs to be first evaluated, and next comes the clean closure and followed by the concatenation operation. So what is inside the bracket? A or B is inside the bracket. So here in the construction of parse tree, what we will do is each and every we will be constructing the parse tree considering each and every term as the regular expression, and then we will be proceeding with the higher level. Okay, from the basis level to the induction level. Induction level in the sense induction is nothing but incorporating operators. Okay, so from the basis level we will be constructing the regular expression. Okay, so here you can see A is going to be, so first is going to be A or B, first needs to be evaluated. So here A is one regular expression, right? So A is one regular expression, and next comes B. So here B is also a regular expression. Let me call this regular expression as R2. So what I am going to do, so this is R1 and this is R2. So for this two I am going to perform the OR operation. So for this two I am going to perform the OR operation, that is this one. Okay, R3, R1, R2 union R3, right? And next comes within brackets. So within brackets, so here this is one regular expression, this is one regular expression, and this as a whole will act as the regular expression, and this again will act as a regular expression, right? So here R3 placed inside a bracket is going to be, so this is R3, right? This is R3. This R3 placed inside a bracket is again a regular expression. So that's what. So R3 within bracket, sorry, R4, R4 is nothing but R3 within bracket, right? And this part is over. So now I have to proceed with giving the clean closure. So R4 should be performed with clean closure, so which is R5. R5 is nothing but clean closure of R4. R5 is nothing but clean closure of R4. So this part is over. So next I have to proceed with concatenating A with this part. Okay, concatenating A with this part. So A is one regular expression. Let me call this as R6, and then it is going to be concatenated, which is R7. So R7 is nothing but concatenation of R5, R6, where R6 is nothing but a regular expression A. Okay, so here next comes, this part is over. So now we have to proceed concatenating with B. So for concatenating with B, I have to proceed with constructing a regular expression. Okay, so B is a regular expression. Let me call this as R8, and which is concatenated with R9. And this is over. Next step comes this B. So here again, this B is the R10, which is concatenated with R11. Alright, okay. Okay, try constructing the parse tree for this one. Alright, try constructing the parse tree for this one. So because directly proceeding, so here the main part is construction of parse tree. So the rest are all very simple, which we are going to use only the rules given. Okay, so first step is going to proceed constructing the parse tree. So try constructing the parse tree for this regular expression. Try now. Let me give you a minute time. Okay, hope you have tried. Okay, so let me proceed here. So here, yes. So here you can see this needs to be evaluated, right? Okay, this needs to be evaluated. So because, so here there are both brackets, okay? So here clean closure. So this will be evaluated, and then after evaluating this only I can proceed with the concatenation operation. Okay, so here in order to proceed with A or B star A or B, okay, so first I'm going to have a regular expression R1, and for this represent it by R2, and then for A or B I have to proceed with, right? Let me call this as R3. Okay, so the next is going to be the brackets. So R3 within brackets, let me call this as R4. Okay, so the next is going to be, so this part is over. So this part is represented by R4. Now I have to proceed with giving clean closure. So R4 given with clean closure, let me call that as R5. Okay, so this part is over. So now what I have to do, I have to proceed. So I cannot directly proceed with concatenation. So first I have to construct a tree for this one, and then only I can proceed with concatenation, right? So here A, let me call this as R6. So please make a note, for this A and this A, you cannot give a same regular expression numbering, right? So this is different, this and this are different. So let me call this as R6, and then this is going to be R7. So for that I have to proceed with the giving a union operation, that is R6 union R7, right? And then R9 is nothing but R8 within brackets, okay? And then I have to proceed. So this and this needs to be concatenated. Let me call this as R10. Are you clear with this? Say yes or no, ma. Why? What happened, ma? I couldn't hear. Am I audible?
Yes, ma'am.
Are you clear with this one? Is that clear for you all?
Yes, ma'am. Yes, ma'am.
Yes, because I couldn't hear your voice. That's, huh? Shall I proceed?
It's clear, ma'am.
Yes, good. Okay, because I think. Okay, so now we can proceed with the construction of parse tree, right? Okay, we can start with now, right? So here we have constructed the parse tree. Okay, so we have constructed the parse tree for A, R, B star, A, B, B. A, R, B star, A, B, B. So now we have constructed the parse tree also. So from this parse tree, I have to proceed with constructing the NFA. So first I have to proceed with constructing the NFA for R1. All right. So how to proceed? So here in this case I am not having any operator, so these two comes under the basis rule. These two comes under the basis rule, and these three comes under the induction rule. Okay, so here what is R1? I am having only the input symbol. So if epsilon or input symbol comes, then we have to proceed with the taking the basis rule. So only if operators comes, I have to proceed with the induction rule. Okay, so here I have to construct the NFA for this regular expression. Please make a note over here. So if initial stage, you will be in a position to move by in a proceed in a step-by-step manner. So after you come across some examples, so some practice, you can, by seeing an expression, you will be you can construct the epsilon NFA directly. In the initial stage, you will be in a position to construct the NFA for each and every regular expression. Only then you can proceed with constructing the NFA for the entire regular expression, right? So, but please make a note over here. If you are forced to construct the epsilon NFA by means of this algorithm, by specifying this Mcnaughton yamda algorithm, then in that case you have to proceed constructing it in a step-by-step fashion. Okay, because that steps gives you the marks. Okay, so this is with the perspective of examination point of view I am talking. So if by in general, so if you are get used of all these rules, you will be directly, you can directly construct the NFA on your own. This step-by-step fashion is not required. Okay, so now we can proceed with constructing for this NFA for this regular expression. So how I can construct? I have to use this rule, right? So here please see here, in order to okay, so here I am going to proceed with the numbering of 0. Okay, 0, and I'm going to have a final state. Let me call this as 1. Okay, so let me call this as 1. And what about the label? This is going to be the label. So this is the label I should give. Okay, so here this state numbering, right? This state numbering, you can go by any of your convention. So it is not mandatory that you have to proceed with this same numbering. You can follow any of the numbering. The only thing is that when you consolidate with our final NFA, the same numbering should be followed. So giving 0 here and finally you are using a different number or different alphabet, that is wrong. So if you are using 0 here, at the end also, in the final NFA also, you should have 0 in this particular, representing this particular state, right? And then this is NFA for regular expression 1, and next is going to be NFA for regular expression 2. So for R2, so this, I'm going to construct NFA for this one, right? So what I can do, so please make a note. In order to have a sequential numbering at the end, I am going for a different numbering convention. Okay, I am going for a different numbering convention. So let me, yes, yes. Okay. So let me repeat. So in order to have a final sequential numbering, I am going with this numbering convention. So whereas you can proceed with any of the numbering conventions. So you can have 0, 1, 2, 3, likewise you can follow. So for sequential numbering purpose, I am going for 2, 3 here. Similarly, I am going to proceed further, right? Okay, so because I know in front I am going to introduce some additional states. So considering that, I am going with the numbering of 2. Okay, you need not go like that. You can go for any of the numbering option. Okay, right? So here, so what is going to be the label here? It's going to be B 4, 5, right? So this is going to be for R1 and R2. So what about R3? So R3 is nothing but R1 union R2. So R1 union R2, what should I do? I should use this NFA. I should use this rule. I have to use this rule. So this is NFA for, this is NFA for R1 and this is NFA for R2. What I should do, I have to introduce two new states and I have to give appropriate transitions, and then I have to proceed with constructing the NFA for R3. Okay, let me show this for your reference. Okay, so please do see here. So I'm going to construct the NFA for R3. So what I should do, I have to have this NFA. So the only thing is that these states will become the intermediate states. So here, whereas in this case the NFA for R1, here this is acting as a start state and this is acting as the final state. This is acting as the start state and this is acting as the final state. So when you are going to proceed with constructing for R3, these states will become the intermediate state, and we have to introduce two new start and final state. Okay, so here we can have this and this. This is nothing but 2, 3, and then here 4, 5. So this is NFA for R1 and this is NFA for R2. I am going to introduce a new start state. Let me call this as 1, and I am going to introduce a new final state. Let me call this as 6. Right, and then I am going to give appropriate epsilon transition. So here epsilon transition, and here I am going to give epsilon transition, and here epsilon transition, and here epsilon transition. Right, so here we have constructed R3, which is R1 union R2. Okay, so next, what is next one? So here R4 is nothing but R3 within bracket. Already we have seen the rule. So what is going to be that rule? So NFA for R3 and NFA for R4 will be the same. Okay, so this will act as the NFA for R4 also. This will act as the NFA for R4 also. So next comes the clean closure. So here R4 is equal to R5 is equal to R4 clean closure. So what should I do? I should use this particular operation, right? I have to use this rule. Okay, so I have to use this rule. So what I have to do? Okay, this is NFA. So here this is NFA for R4. Now I have to proceed with constructing for NFA for R5, which is nothing but R5 is equal to R4 clean closure. So what I have to do, I have to introduce two new states and I have to introduce the appropriate transition. Okay, so here the existing the R4's start state and final state will become the intermediate states. Okay, so I am going to take down these same NFA without the start and final representation. Okay, so the numbering is all the same. I am not eliminating the states. Instead, this is going to act as the intermediate state. That's it. So 1, 2, 3, 4, 5, 6, right? So this is NFA for R4. So what I have to do, I have to introduce two new states, this and this. This is going to be the start state and this is the final state. And then let me call this as 0 and this as 7, right? What I have to do, I have to give all these appropriate transitions. So from this, so here what we are having, from this to this I am having transition, right? Epsilon transition. So from new final start state to old final start state, I will be having a epsilon transition. Similarly, old final to new final, I am having a epsilon transition. From old final to old start, I am having an epsilon transition. This is old final, this is old start, right? So here I will be having a epsilon transition. So here all these are existing labels. Okay, and then from new start to new final, I will be having a epsilon transition, right? So this is with respect to the clean closure. Okay, so the next, what is going to be the next level? So here till this point we have constructed, till this point we have constructed. So what is next one? So R7 is nothing but R5 concatenated with R6. So do we have the NFA for R6? We are having the NFA for R5, but what about NFA for R6? So we have to construct the NFA for R6. So how to construct the NFA for R6? What about the rule we have to proceed with? Do we have you? So what about the rule we have to proceed? So we have to use the basis rule. Okay, so we have to use the basis rule. So what I have to do? I have to introduce. So here, start, final. Just the label will have the input symbol, which is nothing but A. So because R6 we are having the input symbol A. Okay, so here I have to give the numbering. Please make a note over here. Uh, um, uh, this part is going to be concatenated with this part. Okay, so here R7 is nothing but R5 concatenated with R6. This is R5 and this is R6. So these two are going to be concatenated. So what is the concatenation rule? The final state of S and start state of T are merged, right? So these two states are going to be combined. So yes, again, in order to have the continuity, what I'm going to do is, that is, this state and this state will be merged, right? This and this will be merged. So what I'm going to do now is, so instead of introducing a new state, so I'm going to name it as 7 dash. Okay, 7 dash and 8. So let me repeat, you can have it as 8 and 9 even, and 8 and 9 even. While merging, you can choose one of the numbering, either 7 or 8 you can choose. So here in this case I am choosing 7 and 7 dash, right? So here next step is to proceed with giving the concatenation. So here yes, let me proceed with this one. Okay, so here you can see, so this is R5 and this is R6. I have to proceed with performing the concatenation. So how I am going to proceed with the concatenation? So this part need to be merged with this part. Okay, this part need to be merged with this part. That's it. So it's going to be a very simple one. Okay, so this is going to be merged here. Is that clear for you all? Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, good. Okay. Yes, I think you can try it out with this one, right? It's almost time here. Okay, so what you're going to do now is, till this point we have constructed, right? So till R7 we have constructed. Try constructing the NFA for R8 and then proceed with the constructing the concatenation, and try constructing the NFA for R10 and then construct the final NFA. Okay, so we can continue with this in the next class, right? So do you have any doubts, or you are clear with today's session? It is a very simple one, nothing logic behind, only just directly applying the rules, that's it. Are you all comfortable with today's session?
Yes, ma'am.
If